All right, hey, so we're doing find the area of a region in the first quadrant that is bounded by y equals root x, and this line here, y equals x minus 2. Set up an integral and use antiderivatives to evaluate. First thing I did is I graphed this, okay? So basically what we're trying to do is find this green area here, all right? Then I've got a red area and I've got a blue area. So if you look at the red area, it's all of this. If I subtract the blue area from the red, I'm left with the green. Hopefully you're kind of seeing that in my graph. You would want to find the point where they intersect. So that's what this is. You set the two functions equal together and you discover that they intersect at 4, right? They also intersect at 1, which would be down here, but we don't necessarily need that area there. Okay. Anyway, so we want just this green area. So I'm going to basically figure out the red area, which is these red lines. It's all the way from y equals root x down to the axis, okay? Then I'm going to subtract out this blue area. Since it's a triangle, I'm actually just going to do 1/2 base times height, okay, which is 2 and 2. So I'm just going to get a 2 for that one. This integral is pretty simple, and so I just kind of do that guy. I get a 16/3, and the area is 10/3. So that's easy enough, all right? I want to show you a couple of other options that I've seen people do for this one. This, I think, is probably the most efficient approach. You set up a nice integral and you subtract out a nice geometric little shape there, okay? But a lot of people say, all right, well, if they didn't notice that this was a triangle right here, a lot of times you don't notice that this is a triangle and you don't say, okay, I'm going to subtract that out. And so you want to do, a lot of students just say, all right, I'm going to do the whole thing in integrals. So here's different options that I've seen people do for this. So one option would be to take the entire integral of the whole thing, root x, which covers, this will go from your axis to the root x function. And then you subtract, a lot of people say, all right, well, then I subtract out this area here, but they put the bounds from 0 to 4. That's actually going to be a mistake. If you put your bounds from 0 to 4, then it's actually going to include this area that you're subtracting out as well, which actually is a negative area. So that's going to cause you some complications. Another thing that I've seen people do is say, all right, well, I'm going to do the upper function minus the lower function, and I'm going to do it from 0 to 4. Well, the problem with that is that's actually going to bring, that's going to put in a bunch of different areas. And so it might end up kind of actually taking this area down into here, which is going to be not in quadrant 1. So this isn't going to work either. So these are a couple of options that I've seen work. So one way is to go from 0 to 2 for the root function, which would give you basically this area right here, okay? And then add in this, add in the area, which would be this green area, which I didn't fill this in correctly. Sorry, guys. This, add in the area, which would be the upper function minus the lower function, but only from 2 to 4, which I have to fix that. It's going to be root x minus 2 dx. This one would work because this here is going to give me this green area that I'm kind of showing you right now. And if I add that to this, then I'm okay. So this is going kind of like from 0 to 2 and then from 2 to 4, all right? Another way is a lot of people say, all right, well, I'm going to take this whole area here, which would be from 0 to 4. So that's the entire from everywhere below root of x. So that's this whole area. Then I subtract out the triangle. And the triangle, you would write it like this, which is this is basically what I did. But rather than setting up an integral for the triangle, I just kind of went ahead and said, oh, look, area of a triangle is this. So if you look closely, I did this here, but a lot of people might do this with only integrals. Okay. Another reason why you might do it, because it actually says set up an integral. And so you might be thinking, well, I have to use integrals. So this is actually maybe the best answer right here. Okay.